From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
One of the values that I heard, last year, I think it was the average time from new material, like new concept to commercialized part selling orders is about 4 years and $2 million. For LPBF, specifically for LPBF.
That was Daniel Werner. Daniel is a materials engineer specializing in powder bed fusion with experience spanning both polymer and metal additive manufacturing. He previously worked at EMS, where he supported materials development and customer-facing AM programs. He is currently focused on advancing powder bed fusion materials and their transition from R&D into scalable production-ready applications across industry sectors with Inspire in Switzerland. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials qualification or data management support, reach out to the team through our website or via email at info@3degreescompany.com. All right, Daniel, thank you so much for joining the show today. Excited for the conversation. I think we got a lot of paths to go down. But first, like we do with everybody, let's start way at the beginning. So where were you born? Do you remember an impactful moment growing up that kind of helped shape kind of what you wanted to do with your life?
Okay. Yeah. Well, first of all, thank you very much for having me. It's a pleasure to be here. And okay. So I was born in Bacchus Marsh, Australia, which is, maybe I think, on the outskirts of Melbourne, let's just say it that way. And I grew up on a farm where, we had horses and some cows and chickens and things. And that was, very interesting to grow up with, I'd say. The classical Australian sort of cliches, you had to check your shoes for spiders before you put your feet in them. Had to check under the toilet seat. These sorts of things were common practice. And then, what impactful things that happened to me that put me down this career path. I mean, my career path, I guess, changed a lot from when I was a teenager to now. So I, very, very initially wanted to be an actor. So a theater performer, and so I used to do a lot of shows and competitions and things like this.
Were you acting or singing or what
acting,
like all of the
acting?
Okay. Right.
I did do a couple of musicals. I would say pre-puberty couple of musicals, and then the voice sort of started cracking and changing, and then that was it for that perspective. And then it kind of transitioned complete 180 into computer science. So I really then wanted to move into computer engineering because I was sort of very good at that. And then, when I hit the university level, I didn't really like the courses of computer science, but another area that very much interests me was chemistry and psychology. So by the time I hit university, I'd actually changed again to do a double major in chemistry and psychology. And then, that led me to do ultimately an honors year, which is kind of like a shortened master's year in Australia in chemistry. And I really fell in love with that kind of scientific, discipline. It was really sort of interesting to solve problems and always learn new things. And, I was doing very fundamental research, so no real application in sight, just to sort of make new things and see what they can do. And I just sort of fell in love with science during that time. I did a PhD in chemistry, then moved to Germany for a postdoc for a couple of years in Tübingen University and also in Cologne University. And then I got the offer from a polymer company to join as a project engineer or project manager. And that's kind of when I sort of got to learn about 3D printing. So
And with I'd like to go back to the Germany part. So did you want to study in Germany? Was that on your radar? What was that like? I mean, having kind of gone to do a PhD in a foreign country. I know I had a few different reasons for doing kind of going down that path, but what was the appeal? What was that like? Did you have to learn German? Like, what was the, what was the
Eventually,
whole
yes.
like,
Yeah.
kind of experience like for you?
Yeah. So during my PhD, so I did my PhD in Australia. And during my PhD, I had a 6-month exchange semester with Tübingen University. And I really loved the equipment there. I really loved the infrastructure that they had. It was a very professional laboratory. Not that mine back in Australia wasn't, but they just had far more resources available. And the professor there basically said, when you're finished with your PhD, I'll see if I can offer you a position as a postdoc. And I my history, like my family history, is German. Unfortunately, I did not learn German growing up as a kid. But there's a lot of things about German culture. Predominantly, I would say the beer and the food that I really loved. So not only being able to then go to a cutting edge laboratory, but also all the fun, fantastic things about Germany made it a very exciting opportunity to go there. And so for me, it was the job offer, the location. I had friends there. It was a very easy. Hard decision to leave my friends and family, absolutely, but an easy decision from a career perspective.
Were you thinking that you would stay in kind of the academic area? Were you thinking about being kind of doing professor, doing research for as a career?
Yep. That was, I would say, at one time the goal. And it was in my second postdoc that it was kind of like at a turning point where there was the potential or the offer to go down a habilitation. So it's like a 5-year sort of, I guess, program where at the end of it, you would be eligible to become a professor, but not at the university in which you did the habilitation in. And so it was kind of like looking at that option, 5 years of the academic track for not a guaranteed position, then having to move again. By that stage, I was already thinking about getting married and also maybe having kids. Then thinking, okay, that's a little bit unstable, and then I got the offer to move to industry. And then I said, okay, I love academia, really do. I love being able to do the fundamental stuff, but the job security and the stability to be able to support a family, and also the contract was without a termination date. And so it just made a lot more sense for me and my wife, or then at the time fiance, to switch the industry.
Okay. Is your wife from Germany or from Australia?
Yes.
How did you? Okay, see,
Yes.
Got it.
Yeah, I met her in Tübingen, so I met her when I started doing my postdoc. Yeah,
awesome, cool.
And so she's
and so you mentioned the kind of first offer in industry. Where was that at?
Enskimi.
Okay.
Enskimi.
And for people who are not aware of what they do, what do you want to kind of just give a little bit of background on?
Sure. So they're in Graubünden, which is a beautiful region of Switzerland. So it's the factory or the location of the company itself, or the main location of the company itself, is right in between, surrounded by mountains and things. So it's a very beautiful place to work. They are a predominantly polyamide company, so producing polyamides, as well as polyesters. And so, when I joined the company, it was as a project manager in powder-based technologies. And so a lot was done with like textile laminations or can coating or metal coating, these sorts of things. So you're really looking at, the formulation of the polyamide. How can you change the monomers to give it different thermal properties? How can you change, the viscosity of the materials, the additives to give it different stability, and a lot of those things translate very well into 3D printing, especially when you're trying to develop new materials for powder bed fusion, which is what I ultimately started doing at EMS.
And so was that kind of your day job, or what was your day job? Was it like kind of you're a researcher, you're looking at new formulations? Are you doing like more applied, like product market fit of the portfolio of M's? What was your kind of role as it started and then evolved?
So as I started to move specifically into 3D, we were working at that particular time with 3D systems. So we had a partner, and they were, very, very helpful in onboarding, not onboarding me, but sort of definitely teaching me a lot of the ropes, about how to process materials by PBF, what's important from the additive perspective, from the process aids that one would say add into a powder. And my day-to-day at the start was definitely, we had a target in mind. There was mechanical properties that we needed to reach. There was a cost structure that we needed to reach. And so my job was to test formulations, design formulations from the monomer perspective, look to see at what additives, what stabilizers, when I say additives in that case, are suitable for that polymer. So is it miscible? Is it compatible? Does it offer any benefit to the 3D printed part in the end? It was then to, help design the powder size distribution, or the targets for powder size distribution, help with the milling and sieving of the powder, additivating the powder with process aids, and then printing it. But, I had a lot of help along the way from different colleagues. There was like Lars Yende, my boss at the time, very supportive in the fundamental understandings of polymers. We had Christian Stehler or Piotr Zimniak that was very, and Ronaldo Kvetsil, very helpful in milling, and also helping with the powder characterization and print parameter search. Nicole Stockley was very, very supportive in setting up the printer. Like, we had a good team behind us to sort of achieve this goal. But I was responsible for a lot of the the day-to-day aspects of it, I guess.
Do you remember the first time you saw 3D printing?
Yes, it was quite some time ago. It was still when I was in chemistry, and still when I was in Australia. I wanted to make a custom-made bobblehead for my brother for his birthday. And so I looked online, and that's when it was through 3D printing that it would be able to be produced and made. And so I sent off all the photos of him in different sort of positions, and then somebody, made the CAD file or the printable file, and then printed the bobblehead and sent it to me.
That's awesome.
So, yeah.
Does he still have it?
I assume so, yes. I assume so, yes.
And so, to your point, when you were talking through kind of all the different aspects of particle size and the formulation of these powders, I mean, a lot of people in industry, if they've used some of the powder-based processes, I mean, certainly polymers, obviously also metals, but the amount of work that goes into making a powder is extensive. And so I think a lot of people underestimate kind of like, why don't we just grind this material up and throw it in the machine, right? Given your chemistry background, what were your initial impressions of kind of trying to formulate materials for SLS, MJF, 3D printing in general? Did you think it was like, were you coming at it from like, oh, like this seems similar to other things I've seen, or like or was it pretty clear early on that there were going to be challenges to kind of cost drivers, mechanical properties, processing, all of that? What was your kind of initial impression as you kind of came into the field and starting to kind of turn all these dials and try and optimize to get to a product?
Yeah, I mean, cost drivers are a huge problem for material development, right? Because there are, when you set a target, whatever the target is, mechanical properties or aesthetics or recyclability, whatever it is, you'll often find that there is a solution, but it's just not viable. Mm-hmm. And so you're already, when you're looking at a market where, especially if you're working with an OEM, and not just talking about 3D, but any OEM, they obviously want to have as cheap a material as possible. And so you're already significantly constrained about what tools you have in your toolbox to achieve the goal. Yep. That's certainly one aspect. What was probably the most surprising thing would be how subtle changes can have huge impacts on the overall part performance and quality. Like viscosity changes. You can have 15% viscosity changes, and you can go from a brittle part to maybe not a flexible part, but like a part that completely snaps and explodes almost, to one that's got a little bit of give, or contamination is also incredible. Just how small amount of a foreign polymer within the polymer matrix can just ruin the entire printing process. And that's another thing that makes cost a very sensitive factor, because you have to have large volumes of powder just to ensure that the cleaning costs of all the equipment that you're using to make the polymer, be it in the synthesis or in the powder production, is justified.
Yeah, that was going to be one of my kind of threads I wanted to pull on a little bit. Was we've been having some conversations with partners and things like that, other customers we're working with on the part side of 3D printing, right? Where, okay, when does it make sense to use 3D printing polymers versus injection molding? Very common thing. Like they've got the graph, and where does the intersection line go, and what's all the costs that go into that? Because there's kind of the upfront cost of traditional manufacturing and tooling, and versus the pseudo static cost of a 3D printed part, right? But in the same way, you've got on the material side, right? It's not always easy to make small batches of material and then scale it. So what are some of those costs? I don't know if drivers isn't the right word, but it's more like, what do people look for when the ROI to say, okay, hey, it makes sense to scale up to tons of production, or we just got to stay at a few hundred kilograms a year? Like, how do people in the chemical industry think about that? Is with given the complexity and the cleaning costs and the infrastructure costs and all of that would go into scaling up a production line of any given material?
I mean, the business case is the key thing, and depends on which company, right? So as in, you have like let's take Evonik, for example, who has a range of great products, but they won't bother, I guess, with a project or a modification of a polymer without there being a 10-ton guarantee of an order at least
per year,
right?
You think, or is that
I don't know, but
okay.
I think it's like an order. So as in, the order needs 10 tons.
Got it.
Don't quote me on this, yeah. But I'm pretty sure that's they're not alone in this mentality. It's just the sheer amount of work that goes in, not even really 3D printing, but just in any technical application, the sheer amount of work that goes in, right? To develop a new product, test a new product, determine what the specifications of that product are, and do batch to batch consistency to make sure that you can deliver a stable product. I mean, the costs are enormous. And if the customer at the end of the day only wants to take 100 kilograms of it, it's like, well, all right, but then those 100 kilograms are going to bear the entire cost of the production or of the development. And then when someone's looking at a plastic that costs them $500-600 a kilogram, they don't want to buy it anymore. Yeah. And so, if you know what I mean, like that's just a little bit of the reality of it. I mean, EMS is pretty darn good at making tailor-made materials for customers, but there's still a company that wants to make money, and so it's really the business case.
Yep. And is that great? Take 3D printing out of it, or you can include it as well, but in general, like from kind of early development to getting a production run in place or a production order, I imagine you're talking at least a couple years. Is that like an order, like order of magnitude? Is that usually kind of the development cycle that, as you're doing business planning at a high level in chemical companies, that you're kind of looking at?
Yep. So I got these values when I started at Inspire. So Inspire, I'm no longer at EMS, of course. I'm now at Inspire. I got to talk with a lot of different material producers. And generally what I've been hearing is, if you want to take a material, let's stick with 3D printing. If you want to take a material that just requires a slight change. So let's say it's a PA12 type material that just needs an adjustment here or there. It still takes at least 6 months to do the process development, let alone the material development. So just to get it, make sure that it's running well on different printers, and just to make sure that you've got the mechanical properties under control, and the machine to machine variation under control, is at least 6 months. And then you've still got the development time of the feedback loop with the OEM or whomever, to make sure that it's whatever the change was is moving in the right direction, And so you can be looking at, for a simple change, up to a year, for a simple change. And then, of course, one of the values that I heard, last year, I think it was the average time from new material, like new concept, to commercialized part selling orders is about 4 years and $2 million for LPBF, specifically for LPBF. Yep. How true that is probably batch to batch, or it's probably case to case, or how experienced that particular OEM or that particular material supplier was in 3D printing. Like, I assume that it doesn't take Evonik, for their 613 that they released, for example. I assume it didn't take them that long, but that was a value I heard last year, and it explains why the material cost is so high.
Yeah, and with that, do most chemical companies, chemical processors, are they more focused on, once they get a powder, right, like kind of building that moat around it, making it as efficiently as possible, or are they is that 80% of their time, and then 20% is looking at new tweaks and or adjacent polymers and things like that? How do companies think about optimization, increasing throughput, or driving their own cost down versus what's the next polymer out there?
Okay. Do you mean from Arkema or Evonik?
Yeah, just generally. Like big companies like that we've been mentioning, like Evonik, Arkema, any of these, right? They've, from what I observe, and I don't know a whole ton about it, is like once they get their material families or two, right, they kind of stick with it, and then a lot of what they're doing internally to make their business more efficient is decreasing costs, increasing efficiencies, things like that, versus, because of all this upfront cost of doing a new development, and it's going to take a couple $1 million in 4 years, like the amount of resources they spend on that is probably fairly minimal. I don't know. That would be my guess of what that they want. And then a lot of development ultimately comes from smaller companies, maybe. But that'd be my thesis of how the industry kind of works.
Yeah. I guess nowadays, when I first started in 3D printing, when you would go around the Formnext or any of these expos, people were talking about they need more materials, more materials. Hey, we want to make more applications. You can only make more applications with more materials. But I think since then, which was, nearly 7 years ago, and all these materials started surfacing, and a lot of people started recognizing the sheer difficulty of printing new materials. Every printer is a little bit different. And so if the OEM isn't behind the material, you're just going to have such a struggle to adopt it. And it's going to take you, 3 to 4 weeks maybe to adjust your printer setting before you can actually print that particular material. And so if you don't have a business case behind that material that's strong enough to justify the loss in production, then, you won't take it. Right. And so I think because of all these difficulties that started surfacing about, okay, it is very, very difficult to develop new materials, and costly, and they don't run so smoothly, and it's not just press a button and walk away like it kind of is with PA12. I've noticed that there's a bit of a shift in the market, that it's now more gone towards, no, we need to make as much money as we possibly can. We stick to the materials that we know are reliable, and that being, PA12, PA11, some forms of PP, some forms of TPU, and we try to go around the material limitations through design. So try to design the parts now that they can tolerate, the weaker ductility or whatever it is for the application. And so to go back to your point, I'm not sure. I can't speak because I'm not part of the, I'm not really part of the chemical industry anymore. But I wonder if there's that much work being put on the new materials, and rather, as you said, a lot more focus on, okay, how can we make it as cheap as possible so more people adopt the technology, and then the overall price sinks.
Yeah, that makes sense. And so you mentioned Inspire. So do you want to talk a little bit about kind of your transition, what Inspire is, what you're doing now, and kind of your day to day?
Yeah, sure. I'm working for Inspire. They're a nonprofit tech transfer institute based in the main locations in Zurich, but I'm leading the St. Gallen branch, which is the additive manufacturing branch. So essentially, when I was still working at EMS, Manfred Schmidt was the group leader of plastics and ceramics and Inspire. And we, as EMS, had a project with Inspire. And then as that project was sort of concluding, Manfred indicated that he's going into retirement and his position would be free. And then I said, okay, I kind of miss academia a little bit. I mean, I really did enjoy my time at EMS, but I kind of missed the academic side of things, supervising PhDs, thinking about different project concepts, these sorts of things. And so I applied and, I got the position. And then when I started, they said, okay, Daniel, we want you to run metals as well. And so, it's been really interesting. Like metal AM is fascinating. That's, it's different. And it's been a lot to learn, about that type of technology, but it's been sort of fascinating to now sort of, from plastics, ceramics and metals to be on now, not so much from the material development, but the whole, looking at the entire value chain of AM.
And what are some of the most interesting things that you're seeing, kind of taking that 30,000 foot view of these different parts of the industry or different kind of industry thrusts? It's been,
the last 2 years have been really interesting.
Has it been 2 years already that you've been there?
Nearly. It's in 2 months it'll be 2 years, but it's been really interesting. Last year was a hard year for AM, and to many instances, this year has also been a hard year for AM. And there's going to be a crunch that is coming or is already here, and consolidation, which is also going to be fascinating to sort of see. But what I've seen from since starting Inspire to now, what I've been kind of seeing is, especially in Europe, like not a second wind for AM, but a reinvigoration maybe, as post COVID and with like current geopolitical climates, the emphasis on manufacturing competency in Europe and how to improve that and how to consolidate that and how to booster and support European-centric supply chains has kind of come back in focus. And although AM is not going to be the solution to this, it's certainly going to be an important part of on-demand decentralized production. And so from that perspective, it's been really interesting to see how the market's sort of moving, especially for PBF. A lot more focus is coming in on series production, a lot more. Yeah, for that particular technology. Also, probably in response to Bamboo Labs and also let's say the Formlabs desktop printer that has really taken a lot of the larger OEMs markets from rapid prototyping away.
Yeah,
and so it's really interesting to see that and how that's developing.
Yeah, certainly what I'm seeing is, most manufacturers now have some sort of, let's call it a prosumer type of thing, right? Where it's Formlabs or a Bamboo Labs or multiple of them, right? Like everyone has one, right? Like in the lab. And
I can see one behind you, I think, right?
Yep.
There's that.
Yeah. Bamboo. Yep. Why wouldn't you, right? For $1,000 or whatnot, for if you're a manufacturer and have it available, right? But I think the challenge then is like people got like it's like it's good that in my opinion, it's good that it's so widespread. I still think there's a big gap of understanding of like what's the next iterate, what's the next available process that I could use to print parts, right? It's a big jump to go into powder bed fusion, either metal or polymer, right?
Yep.
And I still see that as a lot of misunderstanding. It's just like it's like people don't quite grasp what the art of the possible is, even if they have all these pretty decent FDM or SLA machines.
Yep. Yep, most certainly. I can agree to that.
Yeah. And so with that, I mean, what's the exciting part of that then, as you think about kind of from what you're doing? I mean, can you talk to a few different programs or projects or things, even at a high level, maybe not specifics or what?
Yeah, it has to be high level. So unfortunately, but most certainly. So what's exciting for me as an institute is how I can support these initiatives, how I can support the transition, or not transition, but the improving the reliability of the PBF process so it is a suitable and viable series production technology, right? How can we use artificial intelligence to streamline and improve material production, or streamline and improve material quality or process quality? Are there ways in which we can automate as much as we possibly can, and what needs to happen to ensure automation is possible, right? So, for example, if we're looking into binder jetting, how can we improve the green strength as much as we physically possibly can to make that depowdering step, as cheap as it possibly can for automation, right? These are the sort of things that I find really interesting. Like Inspire has, 15 different groups that are all specialized in a different aspect of the manufacturing value chain, and it's really cool. We have a lot of different competencies and a lot of different expertise in, materials, sustainability, simulation, design for AM, subtractive, hybrid manufacturing, automation. And it's really interesting to see how many of my colleagues can we sort of build, form a consortium to really address a critical problem that's concerning powder bed fusion or even AM generally,
And how, if I'm a company in Europe or even not in Europe, I don't know exactly what kind of where the dotted line is in terms of how you guys work on all your programs. Like how do you engage with industry? Like what sorts of models do you have? Like, is it kind of directed research? Is it, hey, a company comes to you with a problem, a government comes to you with an idea, or like, hey, we want to get better at this. Like what are some of the opportunities that Inspire has at its fingertips to kind of move the ball along on those fronts?
It really depends on what the company needs and what the problem is. So we have multiple ways of functioning, but I would say for AM, the main one is government-based grants. And so typically the way that it works is we would either approach a company or a company would approach us, and we would speak with them about how can we optimize their manufacturing competencies? How can we develop new processes or new products for them? Is there a business that they could see moving into, but they can't yet because, a certain thing hasn't been fulfilled. The material doesn't exist. The process doesn't exist. The application is weakly defined from the design perspective, whatever it may be. And depending on the innovation content of how to solve that solution and the business case behind it, if we've ticked those two boxes, then we apply for public funding. And that's the primary way that we get funding, at least for my group. The other ways are, of course, because we are, specializing in different types of materials. So we're not just printing PA12, we print, all the new ones, that have been coming down the market the last few years. We can also do direct business to business. So a company would pay us, and then we would develop the process parameters for them and print the parts that they want to have so that they can get their hands on it and see, okay, what can this material do? do we see this as being a viable material for our portfolio? And if so, then we do the tech transfer. So we tell them, okay, we printed it on this one and it's this material, or whatever it turned out to be.
Awesome. And so as we kind of wind down the conversation, kind of two last questions. I mean, we've got Form Next coming up, as you've mentioned. I imagine that's one thing that's always on your radar, but what do you expect to see this year? What do you expect just generally in terms of not just Form Next generally, but like looking outward and in the next 6 to 12 months? I think you've kind of hinted at kind of your perspective on the space and the market, but what are you saying from where you sit of things that are kind of coming for the industry?
I'm really looking forward to seeing what's going to be there at Form Next, especially when we looked at what it was like last year. Last year, I would say there was maybe I'm wrong at saying this, but I'm going to say it anyway. 50% international booths, 50% European booths.
Mm-hmm.
There was a lot of international companies presenting at Form Next, and there was a lot less in comparison to previous years, a lot less European companies. Now, maybe 50% is an extreme exaggeration, but it was just maybe how it felt, at least from the polymer perspective. So that was something that was interesting. It's going to be interesting to see how that looks this year. And it's also going to be interesting to see how that looks next year. To see that there's a lot of international interest in the European market, and to sort of see what the response is to that, I guess. From the powder bed fusion, I suspect there's going to be a lot more emphasis on reliability of the process as well as series production sort of capabilities. From the metals perspective, I think there's going to be a lot of quality control optimization and in situ monitoring, these sorts of technologies that are sort of going to be popping up. It's hard to say how it's going to be, but I'm interested to see what develops.
Awesome. And so last question, more of a fun one. We've been putting together our 3 Degrees discussions book list for the year. What's a book? People have been going with podcasts or things like that as well, but do you have something that you've read recently or read throughout your lifetime that has been impactful for you that you'd like to share with the audience?
I mean, Laser Sintering of Plastics is always a good read. But I mean, to be honest, the recent books that I've been reading, because I'm trying to learn German, so I've been trying to read in German. And so the last books that I've been reading were the Harry Potter series in German.
Okay.
Because I remember them from when I was younger, and so it makes it a little bit easier to read.
Yeah.
So that, unfortunately, I mean, because most of my reading is now proposals and publications and grants and strategy meetings and business plans and all these sorts of things. So like leisure reading is relatively minimal.
Yeah. Awesome.
I would say.
Perfect. Well, really appreciate you joining the show today. Excited to kind of continue to see where you guys continue to grow all the efforts that you guys have and continue to make really good inroads in the industry. So thanks for your time.
Indeed. Thanks very much for having me.